Okay, so now that we have our kinematic equations that we'll be using for projectile motion, say if we have a example looking like this, what are some quantities that we could pull out of this problem right here? I'm just going to start to do some erasing over here. Okay. So, one of the quantities that we could be calculating for, or maybe it's a piece of given information, is our is our velocity in the x direction, or possibly the velocity in the y direction. And this wouldn't just be written like this. Maybe this would be the initial velocity in the y direction. And then we'd also have our, like, possibly maybe one of the things that we could be solving for is the final velocity in the y direction. Okay, so here are some quantities that we could possibly be solving for. Or maybe a piece of given information. Maybe another piece of given information is, hey, you know what? We have this over here. It's sitting on some sort of ledge or cliff or whatever. Maybe one of the pieces of information that we'd be given is the initial height. And what's going to be the final height? Well, that's going to be 0 here. We'll have some sort of initial height over here. Anyway, these are two different quantities as well. Well, now that we're talking about x and f, hey, you know what? What about y and f? What about the x? So maybe we will have initial position in the x direction over here. That should be a xi down over here. I think I'm running out of room. And then we have our xf over here. Okay, so we have our initial position in the x direction and the final position in the x direction. All right, and what are some other things that we could possibly be solving for? What about our time? Hey, you know what? How much time does it take for it to go throughout this entire path? I'm just going to do this in green. Okay, and what about what's the whole reason why the velocity is changing? I'm sorry, what's the reason why the y component of the velocity is changing? It's because it's undergoing, it's being subjected to the force due to gravity. So we'll have our acceleration due to gravity, and we know that that's always equal to negative 9.8 meters per second squared. Is there anything else that I'm not considering? I think that's about it. Okay, so now let's talk about the the velocity, the final velocity in the y direction. Okay, so it will be going up at a certain velocity in the y direction, and then it'll come down at a certain velocity in the y direction. Okay, so we are defining this right here to be the final velocity in the y direction. What if we want to find out what the maximum height of the ball is? Well, we could simply just say that the final velocity in the y direction is equal to 0 to find the maximum height. And hopefully that makes sense to you. Okay, so what we're going to do here is when we're given a word problem, we're going to be given a word problem. The first thing that we're going to want to do is we're going to want to write out all of our given information. And let's do this in a strategic way. So let's do this in a strategic way. So what I'm going to do here is this. I'm going to say that when I'm pulling out the given information, I'm just going to have my xi, and then we'll have our xf. We're going to have our velocity in the x direction, and then we're going to have our yi, our initial height, and then we'll have our final height, and then we'll have our velocity, initial velocity in the y direction, and we'll have our final velocity in the y direction. I don't have enough room over here. Sorry about this. And then we'll have our acceleration due to gravity, and we will have our delta t. This is the way that I'm going to write it out every single time we're dealing with these problems. I know that this is going to be a little bit of an adjustment, but either way, I feel like that this is going to be the clearest, the easiest way for you to go about doing these problems. I know that there are many teachers out there that will teach this differently, but I feel like that if you go about doing this in a systematic way, it's going to be the easiest way for you to consistently be able to do these problems correctly and everything. So once again, the way that I'm going to be writing out my my quantities after pulling out, like while pulling out the given information, is going to be in this structure. So we're going to get used to that in a little while when we're going to be solving problems together.